Hello, welcome to the second night of the MSc Creative Computing Graduate Showcase. We hope you enjoy the works that you're about to see. This is the second half of this graduate presentation. If you're interested in following along, you can go to creativecomputing.cci.arts.ac.uk where you can see the projects as the students are talking about them here live. I'm Phoenix Perry. I'm the course leader of the MSc here in Creative Computing, and I really hope you enjoy tonight's work. If you're interested in chatting with the students, they're here while they're presenting, and you can just leave comments for them or chat in the chat here on YouTube. Thank you for coming and welcome.
Hello, my name is Josh Murr. I've just finished the MSc Creative Computing at CCI, and I'm going to try and quickly talk about my thesis work, which is all about getting video-based interaction with deep learning models online. So I can start off by saying that this entire work was kind of inspired by and based on this piece, Learning to See by Memo Acton, which is, to my mind, kind of one of the most important or the best machine learning artworks out there at the moment, and I'll get into the reasons why in a second. But very briefly, in the kind of gallery context, it's a camera pointing directly down at a table with some kind of random assortment of objects like cloths and wires and keys or whatever. The camera is feeding the images of what you're doing, is kind of feeding the video of you manipulating these objects on the table into a machine learning model. Machine learning models interpreting this data somehow and providing you with an output image which is projected or screened in front of you. And the output image kind of takes the form of waves crashing or fire or kind of flowers, some kind of abstract representation of real life kind of textures and feeling. So why do I think this artwork is so important? It provides a very instinctive means of interaction with a machine learning model. You just see these objects on the table, you manipulate them, you play with them, and you see how that is interpreted by the model in front of you. You see, you don't really need to think too much about it. You just kind of walk up to it and you play with it. So there's no prerequisite knowledge required. You don't need to understand how it's working. You don't even need to understand what it might be to at least engage with it. To engage with it, all you need to do is you play with these objects. It shows the relationship between input and output data. This to me is kind of one of the most important things, because although most people, without kind of a deeper knowledge of machine learning and what's really going on behind the scenes, most people won't have a clue what is going on, and they're probably not that interested in it. But to be able to see the kind of the direct correlation between input images, so the things that you're doing on the table, and then the output of the system, whatever that system may be, you can at least kind of start to gain an intuition of the impact you're having on the system. So by moving things on the table or by clearing the table completely, you can see how this machine learning model is interpreting that information. And this all happens in real time. So that's another kind of big thing for me. If this wasn't in real time, I think it wouldn't be as engaging, particularly for people who don't have this kind of deeper interest in machine learning. The real-time element kind of gives you this kind of instantaneous feedback, which I think is important for this kind of like sort of slightly more playful, curiosity-led kind of like understanding of what is going on. And all of this combined, it kind of shows the capabilities and the limits of this system itself. There's kind of quite a clearly defined possibility space in front of you. You've got these objects to play with. You can kind of put your hands in front of the camera, and kind of within this kind of set of constraints, you can see what the model is capable of, but also where perhaps it's lacking in terms of what kind of imagery it can produce. And all that as well is kind of fun, and it's just an engaging thing to play with. So what is gained by moving this online? So the biggest aspect for me is that it becomes free and available to more people. This was a very important artwork for me over the last few years, and it kind of really sparked my interest in machine learning. So if that can become available to more people, I think that's a really great thing. Obviously that's kind of free in quotation marks because you need a computer and you need access to the internet, but there's a lot more people who have those things than necessarily the access to kind of like a gallery in a major city, or wherever this piece may be shown. There's no time limit online. You've got as much time as you want to play with it. There's a possibility that the whole system could become more interactive and users could upload their own models, maybe learn a bit more about how it is working. And it seems to be the first of its kind. I haven't seen anything like this online myself up until now. So I'm not going to go into too much detail about how this is working, but behind the scenes, the model that this is all based on is the Pix-to-Pix model, which is a kind of type of generative adversarial network, a GAN. And a GAN is made up of two halves. There's a generator and a discriminator, which each in their own right are neural networks, except the generator is one that produces data, and a discriminator is one that kind of learns to tell the difference between real and fake data. And this kind of process of combining the two, where the discriminator over time gets better at telling the difference between real and fake data, and the generator gets better at producing more realistic data. So the generator is kind of trying to trick the discriminator, and the discriminator is getting better over time at telling whether the generator is producing real or fake data. So in our instance, the generator takes this kind of black and white grayed out version of what is the target, which is kind of the desired outcome. The generator takes this kind of obscured version, and through this training process learns to kind of produce more realistic output imagery. So it's not quite the target in this instance, but it's kind of, you can kind of see where it's getting closer. The colours and the textures are quite representative of the target image. So a lot of this work was kind of about playing with different size of generator. The generator, at the end of the day, is the most interesting bit. That's the bit that we care about once the training process is over, because that's the thing that's producing images. To get this online, the size of the model really had to kind of come into consideration, because a bigger model takes up more space in memory. It's slower to run. These things aren't really conducive to a good web experience. So shrinking the model down in size, you can kind of see direct correlation of sort of the size of the generator and the quality of the output. So as the generator gets smaller, the quality of the output decreases. Kind of the variation in colour and texture and tone kind of decreases. You can still see the correlation between input and output. The kind of dark spots still produce dark spots, but there's nothing like this kind of variation in tone and colour. So a lot of this research was about finding that kind of like sweet spot, the kind of that perfect size generator where it's still large enough to kind of hold variation in tone and texture and colour, but not so large that you need a souped up computer to be able to run it. The next part of the work was obviously getting it online. So I used TensorFlow.js to kind of handle the kind of finer details of actually running the model online. But as it stands, TensorFlow.js isn't necessarily well set up for this very specific use case, which is kind of video input, video output, which in itself is quite a data-heavy thing to do. So to get it working, a bespoke WebGL wrapper was made for this whole pipeline. The WebGL wrapper takes the input data from the webcam, performs some pre-processing to kind of match that as what happened in training, so it transforms the webcam footage into this kind of blurry black and white grayscale version, packages that data up in something that TensorFlow.js can understand, which is a tensor data structure. That gets sent into the model, and TensorFlow.js handles the kind of the inference, the kind of the running of the model. That spits out some data at the other end, which is then kind of picked up by this WebGL wrapper again, which is transformed into something the browser can interpret as video, and then it's displayed as video as output. So just a few examples. Again, you can kind of see the correlation between size of model, size of generator, and the quality of the output. So in this top example, this is running on a decent GPU, and you can get up to like 10 10, 12 frames per second on a larger model, which is great because you get kind of the full experience of like the increased kind of quality of detail and color and texture and so on. But you need some kind of gaming laptop or a laptop with a good quality GPU in it. The medium-sized generator, which was kind of found to be like the sweet spot, will run on most modern computers. It kind of achieves approximately 14 frames per second on a standard integrated GPU, so you don't really need a high-spec laptop to run it, but you kind of still have to sacrifice a certain amount of variation in the model. And finally, the smallest generator, it's very usable. It's consistently kind of high frame rates on any computer. It's even run on mobile, but it's a very, very abstract output, and I think that kind of detracts from the quality of the interaction. So I think I'm going to show you a very quick demo. So for this quick demo, I'm going to load the clouds, which is the medium-sized model, and there we go, running it. So you can kind of see how bright spots in the input image produce the clouds in the output image. If I turn on the pre-processing, you can actually see what's happening sort of behind the scenes with the WebGL wrapper. You can see how it's turning the input image into this kind of blurry version. The red is just because it's a single channel image and the channel is red, so it's black and white for all intents and purposes, but it's red and white in this instance. Stop that one. I am on a laptop with a decent GPU on it, so I can run the larger model, which is Flowers. So you can see it runs a little bit slower, and I'm also recording my screen, which is going to slow it down a bit more. But it's the same effect. You can see how the bright spots are producing kind of the areas of interest in the output. Cool. So that is all online, and here are some links for you to kind of find out. You can kind of play with the model yourself at learningtolearntosee.netlify.app. Links to more information specifically about the project if you're interested, my website, my contact details, and the original artwork this is all based on. Yeah, thanks very much for watching. I believe that there will be time for questions at the end after all these videos. If you did have any questions, I should be around to answer them. Thanks a lot.
Hi, I'm Moritz. Salla. I have a background in interaction and media design, and I like to call myself a designer, and I like to call code my medium. I'm going to be talking about smart furniture, digital health, and machine learning, all within the context of my final project here at the Creative Computing Institute. For the next few minutes, I'll be explaining my motivation and approach for my project, and after that, I will explain my concept, and lastly, my technical implementation. My final project that I'm about to present is an exploration and a prototype which lives somewhere between the realms of product design and the arts. I really hope that it gets people thinking about how we tackle mental health in digital times. Now, during the COVID pandemic in particular, I spent a lot of time in the digital. So much so that I could personally claim that most of my life at the moment is more virtual than it is physical. My work is digital. I communicate with friends and family in the digital, and in order to calm down afterwards, I sometimes spend my leisure time watching Netflix with my girlfriend, or I game with my friends, also in the digital. I'm convinced my lifestyle is not an exception. As economies and societies increasingly are digitized, our lives turn virtual, and it becomes harder to stay abstinent from digital technology itself. For a longer time now, I have been asking myself the question, how does technology change us? The invention of any technology caused injury to human health in some way or another. The agricultural revolution, for example, made us shrink, caused our jaws to fall out, and reduced our life expectancy by an average 10 years due to the new diet. The internet, in its essence, is a tool, and it is no different. Only that its health effects are psychological, not physical, and often go unnoticed due to the stigma mental health often still carries in modern society. The tech industry is slow to register the need for mental health monitoring. Screen Time, Apple's solution to create user awareness only appeared at the end of 2018, 11 years after the introduction of the original iPhone. Screen time provides no insight as to what a person is doing, is only measuring the time elapsed. Therefore, it cannot tell work from leisure, educational from harmful, or vital from unnecessary. If it were used to monitor the activity of a young child, for example, I can think of many questions that could arise. For example, what is the child doing when they're looking at the screen? Are they playing a game? What kind of game? Chess, a brain riddle, a first-person shooter, or are they reading a book? Perhaps they're looking at obtrusive ads. These are all nuances of user interaction the Screen Time app is incapable of identifying. A significant problem to existing solutions is their restricted awareness of user behavior. Screen Time has access to the amount of time a user spends on which app. Another common solution, internet filters, detect which URL a user visits. In either case, whether or not an interaction is healthy or not depends solely on static factors, namely quantity of usage data, or usage data of quantity, should I say, or block-listed words. I see the use of machine learning here as a technology that is capable of overcoming these limitations, the limitations of traditional solutions. Machine learning can detect nuances and relationships in data. It can supply contextual and holistic insights into what kind of interaction a user is undertaking. I believe tech companies share a mutual responsibility to keep their users healthy and should be invested in finding healthcare solutions themselves. Google stands out as one of the few corporations that are starting to acknowledge this space of innovation. In 2020, the company commissioned London Design Studio special projects to build Envelope, a set of envelopes which temporarily transform your phone into a simpler, calmer device, helping you to take a break away from the digital world. Another work that inspired me was Natalie Jeremijenko's Livewire. It is a piece of string attached to a stepper motor and controlled by a LAN connection. Network activity caused the string to twitch, yielding a peripherally noticeable indication of traffic. To me, Jeremijenko's piece is a simple yet powerful distillation of digital life. This led me to my concept that I like to call the Healing Pod. It is in part a product and in part an artwork that transforms our digital activities into physical form, similar to Natalie Jeremijenko's Livewire. The Healing Orb is an exploration into how smart furniture can promote digital well-being. It recognizes the need for mental well-being solutions in the tech industry and seeks to create awareness. Rather than relying on restrictive measures to enforce healthier content, the Healing Orb explores the notion of self-monitoring. It is an ambient interface that it goes beyond the graphical user interface, the GUI, and adapts to the user's environment. It consists of two parts. The first component is software, a Chrome extension that runs in the background of a user's computer. This collects and processes anonymous usage data. The second component is a wireless IoT device in the form of a round lamp. The latter displays data by setting the hue and brightness of its integrated LED panel. The Healing Orb, in its simplest form, is an RGB, a programmable RGB lamp in a glass enclosure connected to the internet. Its hue and brightness is dynamic and continuously respond to the user's indirect input. A specific tone represents healthy, whereas another represents unhealthy content, and the Healing Orb will slowly fade its color dependent on the reading of approximately the last 10 websites viewed, and hence never requires active interaction. And its appearance can therefore be read and understood by its viewer, yet it discreetly sits in situ like any other item of furniture. Furthermore, the Healing Orb offers a browser pop-up with UI that provides users the ability to set the color scheme themselves, but also to reset the data storage of their system for privacy purposes. the healing orb. As a prerequisite to the healing orb, the user must install a Chrome extension. This extension scrapes website content, predicts its sentiment and toxicity using machine learning, and sends corresponding requests to the Flask server's API. The Flask server is running on the ambient interface. Processing the data is strictly kept to the client side to simplify things. It requires a strong Wi-Fi connection, as the API can get jammed, but theoretically it's possible to connect multiple devices to this one specific smart lamp, multiple devices of one specific user. The Healing Pod's ambient interface is a glass dome that contains a Raspberry Pi running a Dockerized Flask container. You can run the Healing Orb on the local Wi-Fi, and it can be potentially placed freely within the environment if connected to the Wi-Fi. Thanks for sticking along. I hope you enjoyed my presentation, and if you wish to know more, check out my code or my website visible on the slide now. Thank you.
Hi everyone, my name is Yunhan. I'm the student from the MSc Creative Computing, graduate this year. I really appreciate this opportunity to share my work and design ideas. Before coming to the CCI, my background was industrial design. The main design direction is audio and virtual interaction product design. Because of my product design background, I was focusing on designing interactive artworks in this course. Okay, let me talk about my final project. My main topic of my final project is Future Botanical Garden. This is an immersive game that would allow everyone to experience different botanical gardens through digital diverse. This is designed to reflect my own feelings about the future construction of the botanical garden. My purpose in designing this work is to explore the future direction and possibility of the relationship between plants and humans, providing a new perspective on the possibility of future botanical garden. Many artists have their own ways to express their vision of the future, and I'm curious of how the botanical garden will look like in the few decades. My design gives people the opportunity to experience different botanical garden and start thinking about how the botanical garden will look like in the future, and the changes that the botanical garden may face with so many problems that may occur in the future. I will use people's curiosity to experience a new interface method that makes people feel surprised. The game consists of 5 different scenes. In the main scene, you will see 4 rooms, where each of them represent a different world. Different characters have their different stories. Entering each room will bring you into the specific world. Now, let's go to the room 1. Room 1 is called Watering Succulent. In this room, there is an electronic plant that uses data from sensors to grow. The plant will grow according to the humidity and when I spare water on the physical little plant that I designed. The plant in the screen will start to grow. When people grow their own plants and see the result, they feel happy. The appearance of plants very different from the real plants. I use an anthropomorphic interface for people to interact with. This makes sense because cute object or being will make us feel better. Some people use pen to take care of their mood. I hope that through this interactive game process, people will be able to relax and get some spiritual healing. Let's go to the room 2 named Balance Characters. In room 2, I create an interactive world represented by the cactus. In this world, cactus are like inflatable balloons, and their textures and appearance have changed a lot. The user needs to rescue balloon textures tapped in the cube and interact with them. When you click your mouse, the cactus is deformed and has an elastic appearance like a balloon. This is completely different from the cactus that should be touched in really careful in real world. This world allows people to discover interactive experience. This world allows people to discover interesting interactive experience in the explosion and get close contact with futuristic characters. Room 3 is also about biodiversity. In the future, while our plants show up in different materials and forms and become a new form of living things, let us make the impossible possible in the virtual world. Room 3 is a computer art garden, where the flowers are made with code-generated shader and pictures. The world is a maze, and the exit will lead people back to the main scenes. It is completely different from a real garden. You will see flowers up close in 3D space. The original intention of designing Room 3 is that I want to allege the limitation of simulated reality and create a virtual world garden, which of course is completely virtualized. I do not want to bring real things in the real world to the screen. I do not want to bring real things in the real world to the screen. People get to experience and interact with characters that are different from the normal ones in my game. They are completely virtual and different from reality. In the immersive environment, you can think further about the future possibility of plants and their relationship to space. Let's go to the last room. There is a towering tree in this room which cultivated human organs. You can see the square fluid hanging from the tree keeps the organ growing. The big tree feed and help them grow. In the room, human organs and plant organs are closely linked and can grow together. Eventually, humans will use the mutual organ to help those in need of organ transplants. Under the transformation of biotechnology and the genetic engineering, big trees have become completely different, and they can meet the people's needs whilst growing in a better way. I want to convert some idea in this world. On the one hand, I think the word expressed the connection between plant and human genes, the possibility of future life, the prospect of biodiversity. I want to use my imagination to provide an unknown future, a utopian future. Through the rapid development of science and technology, perhaps they will become true in the future. On the other hand, I want to use this room to inspire people that we need to be kind to animals and plants. We use those creatures to do what we want to do, such as changing their appearance and create new species. We use them to achieve our goals. Everything that humans do was not approved by the creatures. However, people keep on doing them. I consider this worth thinking about for all of us. We do not know what a botanical garden will look like in the future, but I will continue to research and create in this direction. There are infinite possibilities in the future, and we determine the life of future generations. I think the first step to realize the future is to imagine, because the people in the past also imagined and work hard for the present life we are living now. I hope my project can inspire people to look forward to the future and realize a better life. If you like my work and if you want to talk to me about my work, please contact me through my social media or email. Thanks for your listening. Have a good day.
Hello everyone, my name is Lan. I'm a student of MSc studying Creative Computing. My game is called Pocket Zoo. It is an AR interactive game for children. Let us learn more about this project. Firstly, I will introduce my project. Before doing this project, I have been looking for an interactive game for children with educational certificates. Therefore, from the perspective of AR technology and aiming at popular science animal knowledge, I developed an application prototype called Pocket Zoo. Pocket Zoo AR is an interactive game for children with the theme of zoo. This game is from an educational point of view, allowing children to learn some animal-related knowledge in the game. This is an interactive game. Children can take photos of animals in reality to interact with animal models made on the screen and learn knowledge in the game. The game has 3 functions. The first function is that children can hold photos or picture books of animals. After the camera recognizes them, an introduction video of the animals will appear on the screen, which can teach the children about animal science. The second function is to recognize the 3D model of the animal in the picture. The third is the camera function. The concept. The original idea of virtual zoo started from the lockdown of COVID-19. It was aiming to help children who are trapped in the home to experience visiting the zoo online. With the development of the idea, the aim of this application beyond providing experience, instead, adding educational function to the AR application makes it more meaningful. The silent goal this AR application established to achieve is to build an contextual environment to deliver sufficient information to objects. In this case, it is about helping children to learn knowledge about animals. The other goal is to provide an experience to help children from the home visit a zoo. research. I did some researches for my project. First is Pokemon Go and its geographic significance. Pocket Go is a very successful game using AR technology in recent years. And I did some case study. For example, Alone Plants is an AR application, provides players with information about plants, which is also the application of AR in the education field. This pictures about in order to make this game useful for kids, I went to the local kindergarten to do field research. And I also did this questionnaire and did questionnaire results chart. Design. These pictures are about how I implemented this technical. And these pictures are about how I cite the model. Well, a homepage for game. This is the interface of the game homepage I designed. Click sign to enter the game. This page is designed based on the audience and related elements of the zoo. Designs that are mainly fun because the audience is children. Interface display. This interface mainly introduces the basic information of animals. After the camera recognizes the animal's picture, some basic information of the animal will appear on the screen. (3D model game interface). (3D model for tiger). The 3D model of the tiger changes. You can click on the tiger's hands or like to interact. Different animals correspond to different models. Last page. This is the interface at the end of the game. I made a design about the zoo vector diagram. Click play again to restart the game. Showcase. This is the game page. Click sign game to enter the game. This is an interface for introducing animal knowledge. The camera will recognize the animal's photo, and then some basic information about the animal will appear on the screen. Click the page. The page will play the introduction video of the animal. These videos will conduct popular science on the corresponding animals.
Smiley family, we love the suggestions. Here we go. We're going to talk some tigers. We're talking tigers today. Animals. Well, I suppose we should start at the beginning. What are tigers? Well, tigers are massive cats with dark vertical stripes. Here's a picture of a tiger, right? Pretty recognizable. Massive cats with those dark vertical stripes that you see. Now, Episode 16, Giraffe.
Click the screen again, and the video will pause.
Tigers have reddish-orange fur, but some have grayish-white fur. You can look at both these pictures.
Take the photo in the upper left corner. You will enter the model interface. Click on the animal's body to interact with the animal. Click Take a photo. You will take a photo with the model, and the photo will be automatically saved on the computer desktop. Click Play again to play the game again. Thanks for your watching.
Hi everyone, I'm Aleksi and I'm going to talk about my thesis project on using generative neural networks for video manipulation. So before coming to the CCI, my background was in mathematics, and that's really been guiding me during this past year as I've been looking for ways of combining maths with art in all kinds of new ways. And I really found a home in this machine learning space where maths and stats are being used to generate art in all kinds of new and creative, interesting ways. I think with what I've noticed is with machine learning is as people are being exposed to these new technologies, it's quite easy for people to associate it with some notion of science fiction, general artificial intelligence, which of course it's not. And I think this can lead to some misplaced trust in these systems and also some unwarranted fear. So in order to combat this, what I wanted to do in my project was really to think about machine learning as a creative tool rather than as some creative entity. And think of ways that artists can actually gain control over this tool and use it to their advantage. So what my project ended up being was a novel method for manipulating video with a generative neural network. So what I think we could do is have a look at this video first and see what it looks like, and then explain the process a bit further. So for this video manipulation process, you need two models: a generative adversarial network, a GAN, and its inverted counterpart, an inverted GAN. So what's a GAN? Here a GAN is described by the New York Times as an AI cat and mouse game that generates believable fake photos. And yeah, that's exactly what it is. So a GAN consists of two parts: a generator that's trying to generate believable images, and a discriminator that's trying to determine whether those images are fake or not according to the data set it has access to. So through this process, the generator becomes very good at generating very believable imagery like we see here. So what's a GAN inversion? So if a GAN maps some vectors into image space, some vectors become images. An inverted GAN would take in an image and map it to some latent vector in the latent space of that generative model, essentially doing the opposite that a GAN does. So what we can do is we can take any image we want, plug it into the inverted GAN, and get some latent vector representation of that image. So how do these inverted GANs work? Now, there has been research on many different kinds of inverted GANs, but the one we chose to use for our project was this one. We used the VGG16 classification network, which is a network used for classification of images. So you plug an image into this network and it'll be able to say, okay, this is an image of a car, or this is an image of a house. But we don't do that with the network. What we do is we pass two images into the network, the image we want to map to the latent space of the GAN, and then any arbitrary generated image from the GAN. And what we do is we pass both of those through the VGG network and retrieve some vector representations of those images. Then we can actually calculate the distance between those vectors, and by using gradient descent and generating new and new images, we can minimize the distance between the two until after 100, 1,000, 10,000 iterations, we retrieve something that looks very similar to the original input image, but it's actually generated by the GAN. And indeed, you can pass any image you want through this process. It doesn't even have to be an image of a face, and that really is the starting point for manipulating our video. So how does this video manipulation work? So here we can see on the left the input video, the raw video footage that we want to manipulate, and on the right side we have the manipulated output video footage. So what we do is we divide the input video into frames, 30 frames per second, and we pass the first frame through the GAN inversion. And as I explained earlier, you pass that image into the VGG network and an arbitrary image into the same network, and we minimize the loss between those for however many gradient descent iterations we want. Then we get some latent representation in the middle. We pass that through the original GAN and get some manipulated image that looks very similar to the original raw video frame. So what we do then is we grab that latent representation in the middle and use it as the starting point for the loss minimization process for the next frame. And we do it for each of the frames in our video back to back to back. And what that allows us to do is avoid the loss function from leading us to different local minima, which it would do if we didn't take into account subsequent frames in our video. And that's really why in this video we can see all these scenes of faces morphing into the background video footage. So in the beginning I talked a bit about how I wanted to grant the artist control over this process. So it'd be cool to now examine what different tools the artist has that allows them to use this method in different ways. And the main point of control that the artist has is this loss function. So by choosing the amount of iterations you want to use in your loss function, you're essentially choosing the level of obscurity in the video, the balance between the face and the original video footage. So a very low number of loss function iterations corresponds to more face in the manipulated video, and a higher number of iterations corresponds to a video that looks far more similar to the original input video. So what the artist can do is really play around with this loss function at different parts of the video and adjust the level of face and the speed at which it's sort of converging into the original video footage. So another thing the artist has control over is choosing which image they want to use as the starting point for the loss function minimization. So here we use the face on the left to initiate the minimization process for the video on the right, and we get something in between both of them. We have elements of the face and facial features blended in with the original video footage. And it doesn't even have to be a face at all. It can be any image, and you can experiment with different looks and different ways that you want your video to look. And it doesn't have to be a face generating GAN either, and you can experiment with all kinds of different models that you can train yourself or find online. And once you learn to balance and adjust all these different parameters, you really start to see how you can gain control over the model and make it do what you want. And that's really neat because we've turned a generative model that we have very limited understanding of how it works and how these faces are generated into a creative tool that we understand and that we can control in many different ways. Okay, that's all from me. Thanks everyone for tuning in. If this raised any questions or you want to talk to me about this kind of stuff, please feel free to reach out whenever. I'll be happy to talk about it. And yeah, thanks, and on to the next talk.
Hi, this is a presentation about my final project in creative computing at UAL. My name is Xiangsong. I am a designer, and also I have different experiences in different industries like music, coffee making. I consider myself as a creative individual. And my project is about understanding and dealing with the negative emotions in video-based communication. How do I start to think about something like this? Why do I make my project into this direction? Is because, one, I think mental health is a common problem in human society at the moment. Over 264 million people are suffering from the depressed emotion. According to the data and the WHO, it says it's one of the main causes about different types of disabilities. And because of the development of the technology and you see the internet and also the development of our devices, people start to work on the computer over paper. So we have something called computer-supported collaborative work, and also during the COVID restriction, a lot of people need to work remotely at home to keep it safe and stop the spreading. So now we work, study, and communicate remotely more than ever. So my topic is trying to dealing with the negative emotions in telework, and I have some research questions out for it. So these are the questions I need to answer at the end of my research. So also, it's like a guideline for me to do this research. Talk about capturing and understanding the emotion. There's one term I want to talk about, which is affective computing. So how do we capture the human emotions? We have a lot of different things that we can capture. For example, your facial expression and your EMG signal from your muscle and your heart rate and your blood pressure, something like that. And another thing in this topic is how do the researchers and how all the designers to dealing with this data. So that's the one thing I think about at the beginning of this project. Talking about the tools to handle the data from the human, we have something called interactive machine learning, which is a types of machine learning. What's different about it is it has the features about machine learning, which you can handle really complicated data and tell the machine to do the calculation for you. And another thing about the interactive machine learning, it's the way how do we train and refine the model. And in interactive machine learning, we combine all of them together. So at this point, user or the designer can refine and train the data with the control, with a proper controlling, and the interaction in this interface is quite effective in my understanding. So you have a loop in the interface, so end user can look at how the system work and tell the system how he wanted it to be. So I think it's a quite an interesting interaction in terms of using the tool. And my concept is to design the system like this, which using the tools and the knowledge and the topics I mentioned before. And this is how the thing look like at the end. So how do so the way how the system work is I have an input from the video capture, and I use the interactive machine learning software Waginator, which was developed by Rebecca. And this is the process of the input and the output. And for the output, I used a very simple graphic, but it has different elements in it to represent your emotion. So how it works is the system capture your facial expression and matching with the output that you said you want. And this is the demonstration video. As you can see, there are 5 controlling bars on the left-hand side window, which is the Waginator. I can make changes to the graphic on the right by changing the bars in the Waginator. I am trying to make a happy graphic by changing the 5 parameters. I'm happy with that, so I tell in the system, this is how I look when I'm happy. Okay, for next emotion, I want to have a confused graphic. So now I'm changing the parameters to make the graphic look confused to me. As you can see, the 5 parameters are controlling the color, shape, and the animation. Now this looks pretty confused, so I'm telling the system, this is how I look when I'm confused. Okay, so next one is gonna be the surprised. Okay, that looks pretty surprised. I'm telling the system, this is how I look when I'm surprised. And I will let the software do the training for the model to map my face to the graphic. So let's try. You see, when I'm changing my faces, the graphic also changes. I'm happy, confused, and surprised. So how do I prove my system is working? In order to do that, I designed a concept proof experiment. So this can help me to know is my system working or not, and also get more information and knowledge about the topic. And in order to do that, I will have a very narrowed down scenario and invite people or participants into the experiment to see how people feel about the system. And this is how, generally speaking, how I designed the experiment. So I will have a set up rooms which have a computer and a video capture devices, and I will run a role play session which is about the job interviewing, and there will be 2 job interviews which has 2 different conditions, and I will be the one who is playing as an interviewer with the participants, and I will get the result from the participants. And for this interview, why I choose this scenario, because it's in common sense, it's a very pressure, it's a environment that has a lot of pressure, and also it's very easy to produce anxiety to the participant. So I think it's very obvious to see how people react or feel in a negative emotion, and people, if my system is working, then people will feel quite differently. That's in my understanding. And I also designed the condition, which is with the system graphic feedback on and off. So that's for testing the differences between, like, have the graphic on or off. Does it affect your emotion? And that's how I did it. And the method of getting the result is, one, after the whole session, I have an interview. I will have a investigation session with the participants, which is, generally speaking, like getting the insights and ask them how do they feel about it, and how do they think about the system, and do they have anything specific they want to mention, which is quite qualitative in terms of making the information for the design. And also I will have a questionnaire which is based on STAI questionnaire, which is a very common questionnaire for measuring the anxiety and the negative emotions in a short term and a long term. For the usage of this experiment, I only used a short term, which is in total should be 20. And I also use the shorter version of that questionnaire because I want to make this process more accessible and more like less time consuming in the data connecting. So I have the 6-10 questionnaire at the end. From the result of the anxiety level, which is the questionnaire data, and it tells me the system might not working as effective as I expected, and it doesn't make significant changes between having the system on and having the system off in terms of the level of anxiety. And another thing which is interesting in my result is the emotion awareness. Most of my participants said that they feel more aware about their own facial express and their emotions. And the main reason of that is because they're knowing there's something on the screen that is capturing your facial express and dealing with the data of that. Even they said that the graphic is not helping, but when they know there's a fact that the system is capturing your face, they will feel they need to be more aware of their own emotion, and they think about more about how do they feel at that moment. So I think this is quite interesting, and the system had helped with the awareness of emotion. And they also said the way we train the system and how do they tell the system to mapping their emotion and the graphic is one of the key features or the key reason why they feel so strong about the system. So in summary, it's really hard to decrease the negative or to helping with the negative emotions in a job interview, and but we can help with the awareness of your emotion and the interaction or the interface design of the system helps a lot with the awareness of the emotion. People think about the emotion more than before. And that's about my project. This is a very interesting project as a designer. Also, I run this project as a part of the research project, and I really hope my design can help with negative emotions. And I know there are a lot of things to do in the future, but this is a very beginning of my emotion research, I would say. And that's it. Thanks for listening. Thank you.